Hello everyone, welcome to the channel. Today we are solving LC-746 minimum cost climbing stairs. So let's read the question and see how we can solve it. We'll first solve it using a basic approach and then we'll optimize it. So let's see what the question says. The question says that we are given an integer array cost where a cost I is the cost of the ith step on a staircase, and once we have paid that cost, we can either climb one or we can climb two steps. We can either start from the step with index 0 or we can start with index 1. And the ask of the question is that we have to reach to the top of the floor, ensuring that we are paying only the minimum cost. Okay. Okay, so let's see, run through some examples and see what is happening. So for 10, 15, 20, I can start from 0th index, which is I can start from 10 or I can start from 15. So let's see both the possibilities and see how things will happen and what will be the cost that will come up. So if I start from 0th index first, so that means I'm here at 0. Now to move any further, I have to first pay the cost, the current cost of this step, which is 10, right? Now, once I'm here and I've paid 10, I can either go to 15 or I can take two steps and go to 20. So let's say that I take one step. That means I go to 15. Okay. Now from 15, once I've paid the cost 15, I can either go to 20 or I can go directly to the top of the step. That is where I want to go, right? My final destination is that only. So I take two steps and I reach there. But I have to pay 15, the cost of the current step, right? That is important. So this means the current till date, the current cost that I've paid is 25, right? But let's see, is this the minimum cost or is there any other way to reach the top paying even less? Okay. So the other possibility that the question says that you can start with index 1 also, right? So if I start with index 1, that means that I am at 15. That is my first step, right? So I pay 15 and then I can decide to take the next step. So that means the current cost that I've incurred till now is just 15, right? Now, either I can take one step, go to 20, or I can take two steps and directly reach the top, which is what I want. I want to reach the top, right? So I take two steps and I directly go to the top, and that is all. That is the end of the question, right? So in this case, my final cost is only 15, which is definitely less than 25. So that is what my answer is going to be, 15. Similarly, if you run through this example on your own, you will see that even in this case, uh, the minimum cost that it is coming is when you take you start from 0 in this case, and then you go and traverse to all different steps, either taking two steps here, then two steps here, then taking two steps here, then taking one step here, then taking two steps here. And if you sum all these values, you get output as 6. So that is the minimum cost, right? So let's see how we can actually convert this solution into our Java code. So first of all, I need a way to maintain at which step I am, right? And to make sure that I am taking the minimum cost, right? So if I start with the basic approach first, so first of all, I would need some way of maintaining the steps. So I'll take an index, right? So let's write another function, our helper function, minimum cost, and this is at index I, and I am passing my cost array. Okay, we'll come to the base case. Now, first, let's see that what are you going to return from this. So you're going to return minimum of the two possibilities, right? How, why minimum? That you are at current step, you take either one step or you take two steps, but you return me finally whatever is actually the minimum cost, right? So it is actually going to be like something like this, that I am at the ith step and I can go to the ith plus one step, or I can go I plus two step, right? but I have to pay the cost of the current step. So this is going to give me cost I. I have to add that, right? I have to return the minimum from I plus 1 or I plus 2, but I have to add the current cost also, which I am already paying. So that is why taking the minimum and then adding cost I. Okay. If we think about the base case is when I've already like reached the top and there's no other cost that is left to pay, right? So if my index, which I'm incrementing in my recursive function, if my index has actually reached or it is equal to my final top, that is going to be my last case. I don't want to do any further thing than that, right? I can simply return. So I'll do if I is greater than or equal to cost dot length. What is my cost? Do I need to pay anything? No, right? I've actually reached the top. So I'll simply return 0. Yeah. Now, even while I have to call this helper function in my original method, I have to make sure that I start from 0 and 1 both and return the minimum of both of these, right? So what you need to do is uh, return math dot minimum again and basically do min cost 0 comma cost, or the other case which is min cost 1 comma cost, right? Because I can either start from 0 or I can start from 1. So this is like the basic solution with exponential time complexity, right? So let's try running it. Okay, it is accepting. Let's try submitting it. Okay, so what is basically happening is that 259 of your 284 test cases are being passed, right? So that means some of them are failing. We need to further optimize this solution. So let's look into the next video that how we can optimize it, and we'll do that using dynamic programming. So in part 2, bye.